offline recording. And we are live. That's
Hello.
cool. Okay, so let me explain the problem. So just for context, because now that we're not having weekly sessions anymore, it's kind of hard to grasp what happened between sessions. So my main idea was to develop, to make the bug fix about how to read a schema. So before it was something completely different, which I actually now that I think about it, it's better for me to show how it was before. So let me go grab the code, the old code here. Um, so let's go to IO. Okay, so here's the code. So the old code was this thing, and there are two main problems with this approach. Let me just confirm if my audio is going okay. Yes, it is. Cool. So the first problem is that this is very imperative in terms of implementation. We are using a for, and the main reason that I wanted to use for in this thing is because I really dislike Racket destructuring. So I could not do a fold with two things in the accumulator because that would be very annoying using car and cadar in order to destruct them and stuff like that. So I decided to just use a for just for the sake it was like 4 a.m. in the morning. That's the first problem. The second problem is that this is not following the serialization the format that we have. So let me explain the format. The format is the following. You have a line, which is the name of the class, which actually is going to be now the name of the struct. I actually want to try to preserve most things as we can. So the entire serialization thing, we should just swap sends with function calls, and everything else should be basically the same.
Okay.
And then, but going back to the format, so you have a name of the entity that you want to you are about to deserialize, and every single line is gonna be a one entity. So this is one procedure. So the first time I did it, it was working fine because I only serialized these things. But then in the middle of my epiphany, I said to myself, okay, so what about having two tables? If you have two tables, the serialization will work as expected. So we have two tables here. But the reading of that back was completely wrong. Why? Because it is assuming that you have like a odd even situation. So every single
Oh,
even case is going to be a name of the entity, and every single odd case is going to be data. So
I
that was
see.
an oversight when I first did. But my initial plan was, okay, this is very easy to solve. I'm going to get rid of the for. I'm just going to use a fold. And instead of using like some sort of odd even logic, I'm just going to like read the line, check if it is a name within our hash map, which is the entity class's hash map, and if it is, that means that it is actually an identifier of a class. Otherwise, it's going to be data, and then we need to accumulate during the fold process. We need to save the last name of a class that we have that we read from the file. So far so good. So that's exactly what I did. So this is the new version of the same thing. I decided to be a little bit more readable, so I made the smaller functions that will do the things that are very ugly separately. And then I got rid of the for. I used the fold. Um, and again, I'm very bothered by this lack of destructuring. I tried to use define values, but that didn't work. And I don't even remember the error message anymore. Uh,
Yeah, you can actually use define values. It's just that you would have to do something like define values, then open paren, the two names you want, close paren, and then values, which
yeah, I tried using
they,
values as well instead of consts. I tried using values here, and then using define values inside the lambda. That didn't work.
yeah, no, you would have to put the cons in the fold as it is, and use values inside the lambda as well, because I'm pretty sure fold doesn't allow you to use multiple values in the accumulator. I
I'm pretty
know
sure
it
that that's true. I'm pretty
Yeah,
sure.
I know it should allow you to take like multiple values per step, I think, but not in the accumulator. It's just one value there.
Yeah. Anyway, I surrendered the battle and just used this, and it worked. Actually, everything here is right. Like, I'm pretty sure that if you remove the prints that I used for debugging when it started to go wrong, it's gonna work just fine. The problem that I just discovered, like, like I had the problem. I didn't assess the cause of why it's not working. And let me actually show you how I discovered it's not working. So let me explain. So I use some prints to identify. Okay, I create a table in this let block up here, and I want to know inside the programmer table in the schema within the field name. I want to get the type of this field, and I want to know its byte size. So
Mm-hmm.
I made these two lines here about programmer name and editor, which are columns of the programmer table, and then I write it to the disk, read it back, and then do the same commands again. Why does that matter? Because they should be the same. If the entire serialization and deserialization are right, and that's when I
Yeah.
discovered that they aren't. So my first hypothesis was to check if the serialization was working correctly, and it is. So that's what these other nasty prints are checking for me. So I'm 100% sure that writing to the disk is 100% correct. So I was sure that the problem is in the reading process, which means that it is in the deserialization. And that's like when I understood that it was there, I started adding a bunch of prints to this function here, which is the function that deserializes everything that is in a hash map. So we're talking about we have a hash map of entities, right? We have tables and procedures. We have inside a table we have a hash map of fields. So
Yeah.
this is the whole trying to be generic and still trying to use the modern inheritance system. But then I discovered a thing. I did a bunch of prints, like print, 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 and everything seemed fine. Everything seemed fine. And I slept very bothered by this because I couldn't assess what is going on. But then the morning of the next day, digestion happened, and I had a moment. I had a moment, and the moment told me what was wrong. So
And
the
what was
hypothesis
wrong?
is that this is not a copy. This is a pointer. That explains the bug, and let me explain why. My first hypothesis was that when I saw that the prints were different, I was very bothered because sometimes with like if I change the table to the table car, for instance, everything would be fine. But then I noticed that everything would be fine because the sizes of the fields that I was manipulating were the same size. So it was 5, 5. Then I decided to change all the numbers. So now we have a 5, we have a 7, we have a 6, we have a 4 somewhere. No, we don't have a 4 anymore. Okay, so we have a 6, a 5, and a 7. And I noticed that when it was deserializing back, all the fields with all its types, they all had the same size. One of these, right? 7 or 5 in the case of name editor in the case of this table here. It was always
I see.
following I think the 7 because the 7 is the position 0, which means that it's the first column of the table. Then it got me thinking, how the heck is possible that throughout my loop, because this is the just to give you a little bit of context, this method is recursive, this thing. So it is called the serialized hash list, and here we are calling it again.
Yeah, in tail position even.
So my hypothesis was, if this is not a copy, if this is a pointer, this explains everything. Because now
It
it
is a
means
pointer.
that what I'm actually folding over, because effectively this recursion is doing a fold, what I am actually folding over, I'm saving the reference. And throughout the fold, the reference will be pointing to the last iteration of it. Or the first iteration of it, doesn't matter. I don't know the details of Racket in this sense.
It's the first. You see, this is a pointer, in fact. It's actually a reference to the object that received the message sent. So, you know, it's like in Java, basically. The
Yeah,
whole object system is pretty much inspired by Java. It's like, oh, they needed they needed something to teach object orientation because Racket is widely used in academia for teaching.
yeah,
And then they based it on Java because Java is by far the most popular OO language. So basically the same semantics, which means that this is in fact a pointer to the object that got the message. And since the first object to get the message will be obviously the first object you parse, and then you put the this in the accumulator and you just keep passing the same this over and over again in the loop.
exactly.
You are
Then,
always referring to the first object.
yeah,
Yeah.
and just to be even more clear, because probably Marinho already got it, but just for the sake of someone is crazy enough to watch this, let me explain why this is a fold. So, what is the purpose of the serialized hash list? You have a bunch of bytes, and you have an accumulator, which is in our case is a list. We have a function that we're going to use separately, which is exclusively dedicated to deserializing names, because as we know, and you can see that actually happening here. No, not there. There. As we notice here in the schema, there are a bunch of names here, like model and varchar and year and integer and stuff like that. So the purpose of this is exclusively dedicated to deserialize the name of it. Then we check if the byte stream is already done when we receive it. If it is done, that means that we just return the accumulator, right? If it's not, that means that we need to do a bunch of stuff because we're gonna have a pair of name and data. So the first thing that we do is to get the name, get the name. Then we get the oh yeah, this function actually tells you two things, right? It tells you what is the name deserialized and how many bytes you consumed from the byte stream in order to deserialize it. Cool. Then we grab the name. We grab how many bytes we consume to get this name deserialized. Actually, this is the name, so because this is a tuple, right? This is a pair because of the counts. So one is doing cadr and one is doing car. So this is how many bytes you consume, and this is the name. Then this is where the thing gets crazy, because now we use the how many bytes we consume to jump them over, and deserialize the rest of it. And every single deserialization method in all the objects, they all return you how many bytes you consume to deserialize whatever you want. In this case, it's going to be this. So to deserialize this, which is going to be the subclass, right? Because hashable, for the sake of completeness, hashable is the superclass that we're going to use for everything that is going to be accumulated in the hash map. So we're talking about fields, we're not talking about entities overall. So in the case of deserializing entire schema, this is going to be a table potentially, or a procedure. In the case of deserializing a table, this is going to be a field. Okay. So then we know how many bytes it took to deserialize one field, right, or one entity. It doesn't matter. With that set, we just call the method again recursively, jumping all the bytes that we know we already consumed and we update the accumulator with the name of the entity, or the name of the thing, could be field, could be a table, whatever, and the thing itself. And then we go that throughout all the hash map, everything. So multiple fields, multiple tables, multiple procedures, it doesn't matter. Everything is going to work exactly the same. The problem is that I thought that this was being like, for some random reason at the time, I thought this was going to be a clone. But it isn't, because as Marinho said, it is a pointer. Then we go to the attempt of a solution, which is to, does Racket have a clone for objects in which I can like deeply, I think that's how we call it, right? Deeply clone it. So I'm not only copying the reference, I'm copying what the reference is pointing to. And I send that message to the Racket server, and nobody gave me an answer. I found that structs do have that. It's called like something like strict copy or whatever.
Yeah, but if you're using structs, since their fields are immutable by default, you usually don't need to use that actually.
that's cool. But then that's our roadblock, because there are two ways to solve this. The first way is to change the format, or this format here. So if we change this to always be like coupled, so for every single procedure you're gonna have the name procedure and the content. If you have a second procedure, you're gonna have the word procedure again and the content. Instead of having like one single identifier for a series of data, it's gonna be one-to-one mapping, like they come in couples. That may work because that may work because we would not have we would have to change this guy to, instead of working like in because it was designed to work with these things. We will have to change it to accommodate this new format. But I think that this is a perfect opportunity for us to just say, okay, let's reassess our options. Our options. So I thought about it during today, and I think that's not going to be a big problem to just screw this. Let's nuke this, and let's try to do the way that dynamically typed people do things in Racket, which means that we're going to use structs and we're going to check stuff afterwards with predicates. My first initial fear was that this would be very hard because we would lose a bunch of stuff. But after thinking more about it, we're gonna lose this for sure. This entire file is gonna be nuked. But I think this file, not really. Not really. Because the only thing that's gonna change is that instead of having sends everywhere and get fields of sorts, we're gonna just change those to whatever structs use. And everything should be the same. So that's why I changed my mind. And I think we actually can um, um, kind of safely, instead of using classes, we use structs. So this is the entire context.
By the way, before we actually get into that, I have a question.
Go.
What happens if there's a new line in the data you're deserializing?
That's a very good question. You know why that's a good question? Because I already solved that problem. So
Oh,
let me explain. It is in fact possible to have a new line loosely like in there. And we suffer this problem because this guy here, this guy here, it has a new line here. It has
hmm.
like as the slash n there. Then that's where I made this function here. I made this function called fix empty read byte lines. So this function, it's exclusively dedicated to rearrange the lines because what we're gonna do ports byte lines, right? So let's go to IO real quick here. As you can see here, port byte lines. And then we may suffer from the problem that Marim just noticed. That it is possible because the data is it's like random data effectively. You don't have control of whatever is coming. How the heck are you gonna treat the random empty new lines? Huh? That's easy. You just detect them. You detect that that is empty. If it is empty, you need to push a new line to the next one. Not actually the new line. You need to push the bytes that represent the new line in the next one. So that's basically what this thing is doing. And again, because I really dislike Racket's destructuring, I use the actually this is even more cursed because this is using a fold with mutation and then a while after. Uh, but anyway, that's how I solved it, Marin, because we did run into that problem before. So what this is
Okay.
effectively doing when we separate this, we're gonna have an empty new line because here there is a slash n, and then we detect that, and then we say, oh, go the line immediately after those, just add at the beginning an bytes that represent slash n, and that fixes it. Okay, any more questions?
Not for now, no.
Okay, so let's start by type. Actually, let me ask you, what do you want to start with? We have literals, we have tables, fields. I would recommend going with types first.
Um, Type. Actually, we need to go with the super types first, bytable, serializable, and hashable. Because the way structs work and the way they do polymorphism is you have something called a generic interface, which is kinda like a Java interface in that um, you declare a set of methods that must be implemented, and then when you define a struct, the struct can implement those interfaces, and that's how structs do polymorphism. And that means we should start first by defining the interfaces because we need to refer to them from the structs we
I have a
write.
question.
Sure.
When you have, what did you call it? Super interfaces?
Generic interfaces.
Generic interfaces. When you have those, are you going to define only like the contract, what you need to have in order to implement an interface, or you actually can provide implementations for those that implement the interface?
Um, it's a little bit of both. By default, usually you only provide the function signatures. Um, you can provide default implementations for types that are built into the language, like vector or string or stuff that you wouldn't be able to, you wouldn't be able to implement it afterwards because it's built in. Like you can't do that. And you can also derive some methods. So like if you have a method A and a method B, and from the implementation of A you can derive B, you can actually do that as well. So that's an option.
Okay, let's go slowly. Let's actually go with the one with the default implementation later, because that's actually where the hashable comes in. Because this is I want to be able to maintain this implementation in the entirety of this implementation aside from this. Um,
Okay.
but that's
Um,
the thing. We need a mechanism that allows us to provide a default implementation, such as SML modules, Haskell type classes, and Rust traits. After you define the contract, you gain things for free. Um, but let's go after that later. Let's go with the easiest one. So serializable and bytable. So how do we do these two generic interfaces? How do we do that? Let me actually start
I
searching about it.
I actually sent a link in the call chat. Uh,
Is this the one?
yeah, that's the one,
A lot of English, as always.
as always.
Uh, a lot of English,
But it
as always.
but it has examples, so it helps.
Yeah, no, I'm not saying it is bad. Like, just to be clear, before anyone starts to hate me, I'm not complaining that there is documentation. I'm just saying that I'm not a fan of the ratio of natural language to Racket language in Racket's documentation. It bothers me a lot when I am reading something. Not this necessarily, because this is talking about the generic structure of this, but there are very, very other scenarios in which there is a definition of thing, which like code a quote unquote type signature, and there's only the English stuff. And usually, I just prefer to parse Racket, right?
I
Um,
see, I see.
to parse Racket instead of parse English. Okay, so
That's
this is
fair.
an
That's fair.
example of defined generics. So we have a printable stuff. What is a gen print? Are these like the methods?
These are the methods, yeah. So it's
Ah.
it's kind of like, you know how when you do define and then you define a function, it's kind of like that, except there's no function body.
And what is it? What's going on after? So this is what this is saying. What this line is saying here.
Okay, so this says there's a method called genPrint. Um, the printable, or in other words, the struct that implements this will be the first argument. And then you have an optional second argument, which is called port.
Wait, repeat the printable meaning again.
Printable, which is the same name as the interface,
Yeah.
is denoting which location in the positional arguments the implementation, the interface instance will be. So like, if you look at the next line, genport print, you see that printable is actually the second argument. So it doesn't necessarily have to be the first. It usually is, but not always.
Ah. Wait. Wait. Are you saying to me that this n is printable? Is that what you're saying?
Yes.
Okay. That's weird, but okay. Uh huh. Okay, so what the heck is defaults? What does the is this a default
Basically,
implementation?
yeah, those are actually implementations for types that are built into the language. So like you see that there's an implementation for strings,
How can you
and
define
then
if something is built-in a built-in type of the language? Like are hash maps
you
built-in?
know, uh, technically you can consider them as such because they are implemented in the language itself, like as part of the standard library, which means it's not something you control, which means it's not going to implement your interface, but um, you can provide the defaults for hash maps if you just put the hash map predicate as the
One
first
second.
item of the defaults.
Sorry, 1 second, Marin.
Okay.
Sorry for that. Can you go back again? I
Yeah,
apologize.
so I say I say built-in types, that's kind of the intended usage, but technically you just say, look, even if the type does not implement the interface, but if it passes this predicate, use those definitions. So in this case, in the example we're looking at, there's a default implementation, but it could just as well be a default implementation for numbers or for hash maps or for vectors or whatever you want. And the reason this exists is because built-in types from the standard library or types from third-party libraries that you don't control, they will not actually be able to implement your interface because they were implemented first, and then you implemented your interface afterwards, and then they had no way of implementing your interface back then because it didn't exist yet. So with the default clause, you can provide implementation for those types that already existed before.
Oh, okay. Cool. Uh,
Yeah, and you see, you have a couple examples of structs implementing that interface, and you will notice that each of them has the three methods implemented.
yeah, genPrint, genPortPrint, and genPrint star.
Yes,
I forgot the syntax. Is this optional, or is this only like to avoid positional arguments?
that's to avoid positional arguments.
Yeah,
Optional arguments in an interface, they're denoted by wrapping the arguments in parentheses, or you could use square brackets or
oh, I
curly
see.
braces because they're equivalent in Racket.
Okay, next question. Am I obligated to, in order to have the printable interface, am I obligated to implement all of them? If I am not one of those default ones?
You are not, but I think there's an option to force a list of methods to be implemented. There's a requires clause you can add to the interface definition.
Okay, but anyway, that's not actually, that's good to know, but that's not actually what the serializable is going to do anyway. So it's going to be define generics. I actually need to see if this requires anything or this is in the base. This is in the, oh no, it is in here.
Bracket generic, yeah, bracket slash generic.
Okay, let's
Uh,
just dump it in here. Cool. Define generics.
I
Um,
think actually I remember posting when I was first looking at this stuff an example that does kind of what you're doing right now in the RacketowerDB channel on Discord.
wait, what exactly you remember?
Yeah, just let me double check for a moment and then place.
Okay.
Where is it?
We're not gonna have defaults, obviously, because everybody needs to tell how the serialization is gonna work or not. Oh, actually, that's actually another thing. Can I enforce more stuff using define generics aside from the presence of the methods? Like, I want to every single method of the serialize method of the serializable interface, I want to tell it it needs to return this. Can I do that?
Not on this level, but you can provide it when you provide the methods outside of this module, you can wrap them in a contract that does that checking for you. I'm not sure if there's a
Ah.
way to, yeah, I'm not sure if there's a way to enforce it like when you are implementing the methods, the interface.
No, but I think
Let's
having the
see.
contract is gonna be already good.
Yeah, I don't think
Uh,
there's a way to enforce it at the implementation time, just at runtime, unfortunately.
okay, that's
But
not
yeah,
a problem.
you can totally export the methods with a contract around them, and the contract will check the types for you. So
That's awesome. That's awesome. Okay, next
yeah,
question. So, how does it work? So we don't need these, right? Because the serialize is gonna take the struct itself and it's gonna return a bunch of bytes.
yes,
The
yes.
deserialize though, deserialize, it takes. I think
It has to take.
I'm gonna maintain the serializable first, and then we're gonna have a byte stream here.
That works.
Uh,
Um,
I think it would be good to also add like that. What do you think about it?
yes. Since this only has two arguments, I'm not sure that I would do that myself, but sure if it works.
Oh, we're talking about removing this then.
Yeah.
Okay, that works. Okay, next one. So we're gonna remove this. Um, Actually, before we do all of that, I should check out from it. Uh, am I willing to lose the fold? That's a good question. Um,
Could
I
always create a
didn't.
new branch.
Yeah, but I didn't commit. Hmm.
Oh,
Okay, let's do the following. Let's do checkout of a new branch. Um, I don't remember. We have main or we have master. We have master. Master. Okay, I brought all the stuff with me. Um, let's create one struct by OOP. Okay, now you're safe. Now you're safe.
yeah. The funny thing is, we're still kind of doing OOP, except this is Racket style OOP instead of mainstream OOP.
Yeah, which for sure is already totally different because we're not gonna use inheritance, for instance. So
Yeah, no,
Java people have a sin, and I'm okay with it. Biteable. I have another question. When you're using generic interfaces, is it common in terms of convention to name it with the thing?
it's not actually.
Because there was a comment in one of the videos explaining that this is actually not an obligatory thing. This is only a convention.
Yeah, that's a convention for the OOP stuff, but it's not used for generics normally.
Yeah, I already forgot. Does the from byte stuff actually require something? Oh yeah, the from bytes actually requires something, and the 2 bytes doesn't need anything. Okay, so we're gonna have a byte stream here. Oh,
The other
and
one is
through
two
now that we are doing
bytes.
it from scratch, I think it's good. It would be useful to explain in more detail. So, why do we need serializable and why do we need byteable? We need serializable in order to enforce the serialization methods, and we need the byteable in order to be able to tell how many bytes something requires in the disk. So
That makes
that's why we
sense.
need.
That makes sense.
That's why we need those. Um, okay, now we can get rid of that.
Yeah,
There.
just one last thing. It's probably a good idea to add a requires clause to the interfaces to make sure that both methods of each interface is implemented.
Do we have this here?
Yeah, there's
Require.
I don't think there's an example for that, but if you go right at the top at the syntax description, yeah, see, you put the keyword requires and then it's followed by a list of method names.
Okay, so we're gonna put that for sure. So it's here, I guess. Is that? Or I need to put that
It
like
can
in.
be anywhere, really.
Oh, it can be anywhere. How do you tell that you only require one of the methods?
Uh, the list that follows the requires keywords will have a list of all the methods that are required.
I
So
don't know
if you
if I
only
follow.
put
Let's suppose that I want to enforce from bytes, but I don't want to enforce to byte size. How can I do that?
Okay, so after the requires keywords, you would do an open parent or a square bracket or whatever delimiter
Mm-hmm.
you like, and then you just write from bytes.
Oh, so if I don't put anything, it assumes that it is everything.
I think you actually have to list everything you want. Like the default is to not enforce anything, and then
That
requires
sucks.
lets you. Yeah,
It would be
kind of
nice to
does.
have like, if you don't put nothing, I'm gonna require you to have everything. That would be very nice. Very, very nice. This, no. This serialize. There. Okay, so far so good. Uh, so we have these things.
Yep.
Let's not go to the hashable for now, especially because I believe the type is not hashable. Yeah, type is not hashable. So we are good to go. So now we can go to structs, I guess. Oh, let's make the contracts first.
contracts could be fine, I guess. They're actually not very difficult to do. You just have to require Racket/contract first.
Okay, so we're gonna have a new guy here. How do I do that? Let me search. Contract. Aha. Okay. Contract
Um,
combinators. Oh, there's a lot of stuff.
yeah, there's a lot of stuff. Racket's contract system is very extensive. Like it's used a lot. It's used everywhere basically, and it's very
um,
detailed.
which topic are we looking for here? Because I don't think it's data structure contracts or functional contracts.
Attaching contract to values, 8.6.
Ah, contract out. So we have a module and then a function. Ah, okay. I
Yeah,
think I got it. I got it. But now
it's
the
it
question is,
has
how the heck you do that in with interfaces?
each method is basically like a function, so you just do it as if it was a function, and that's
Are we
it.
gonna do that like within the definitions of the generic, or are we gonna do that outside?
Usually we put it on the provide clause
That's
um,
weird.
because otherwise, this is what happens. If you put it directly in the definition of a function inside of your module, you have to do the contract checking inside your modules, like as you call the function, which adds a lot of overheads possibly.
Okay, I'm not a huge fan of separating this stuff. I like to have them unified in one single place, but I guess it's okay. So what this arrow means?
That's a function contract.
Oh, okay. So I can establish things for things that are not. Oh yeah, data structures. That makes sense.
Foreign values as well,
Ah,
though
okay.
that's less useful.
Okay, that's very cool. So I'm guessing these are the inputs and this is the output.
Yeah,
Okay. So the serialize, how the heck we do that? We do bytes,
yeah.
and now we have a problem. How are we gonna put the input? Because we actually don't
See,
care. No, actually, yeah, we only care that it needs to be something that implements the serializable. But I don't think that there's a way to connect those two things together.
actually there is, because when you define an interface, you don't only get the interface name and the methods, you actually get a couple helpers as well, including, and get this, a predicate that tells you whether a type implements the interface or not.
And is this predicate dynamically generated? How does that work?
It's dynamically generated and it takes the name from the generic name, so in this case it's serializable, and it literally just adds a question mark at the end.
Okay, I gotta say that this is cool then. Like I'm not a fan, just to make myself clear, because if somebody ever watched like 5 minutes of the latest, the one of the last Camelot sessions, you're gonna know that me and Magneto we hate this dynamically generated stuff. It gave us a lot of headache. We hate it all the way through. But if it works like what you're saying, it just adds a question mark and you gain that for free. If it works like that, I'm okay with it.
Oh, and you should probably remove the parents from the serializable. Like, you don't need it there because it's just a flat predicate.
Um,
Oh, and by the way, you can put multiple things in the same contract out, so you don't have to repeat the contract outs multiple times.
okay. So you're saying that I can do like this.
Yes, you can.
Nice. Okay, question for you. My
Yes,
understanding is that the deserialize is going to receive bytes. It's going to actually it's going to receive two things. My bad.
yes,
So it's going to receive two
serializable and
things
bytes.
and bytes.
Actually, yeah, that's actually not how you do the contract. The way the contract for function works is it takes an arbitrary number of arguments. The last argument is the contract for the return, and then the other arguments are the contracts for each positional argument. So you don't need the parens there.
Wait, now I'm confused. Why is he doing that in the documentation? I thought it was because...
Because that's not actually two values, it's actually a single value. See
Oh,
the
there's
end
an
slash
and
c.
here.
Yeah.
Okay, okay, okay. Sorry, sorry then. So there's no thing here. And actually what we're gonna return is a serializable.
Yep.
Okay, that's cool. Okay, let's do the next one. So the next two ones is byteable. So let's start with from bytes. What from bytes requires? It requires something that is byteable. It requires bytes and it's gonna return
Byteable, right?
mm, not really actually. It's gonna return a number, right? Am I right? I already forgot. What
I
is this
think it's two
returning?
bytes. I think it's 2 byte size that returns a number actually.
Oh yeah, actually that's true. Yeah. This returns a new thing here. Yeah, that's for sure. So it returns byteable. And then, oops. Then here we're gonna return, I don't know, real, I guess. Actually, I want to be more specific. Can I say integer?
You can, and actually Racket is pretty cool in that way because there are a lot of predicates for numeric types, and I think in this particular case, the one you want is let me just check if I have the name correct.
So
The
the
one you
other
want is natural,
one.
probably.
Ah. Okay, so they are using fancier names, which I like. And then this only requires byteable actually. Okay, so this is the contract actually. So yeah, we can already remove this.
Yeah, and for the provide, besides the functions you are contracting out, you probably want to provide as well the predicates, the serializable and byteable, because
How
you're
do I do
probably
multiple provides in one single provide? I always use multiple provides because it's easier to just remove if I want.
you can just put up as many symbols as you want in the provide, and it allows you
Actually,
to
what
do
is the
that.
convention? Do you guys prefer having one single provide with all the stuff or one single line for each one of them so it's easier to remove?
Uh, I usually put everything in a single provide. There's no reason why you can't break the lines inside the provide clause. So like, if you prefer to do it that way, you can. But you don't need to keep repeating provide, provide, provide like many times. And usually we like to put the provide at the top of the file actually.
Uh, okay. You put what on top of the provide you said?
We like to put the provide at the top of the file because you can put it anywhere, but since when we look at the modules implementation, we usually want to see what the module exports. We put the provide first because it's the first thing we want to look at. And then inside that provide, you can put as many symbols as you want. So you can
Okay.
just put them all in one place. And if you like to have them in separate lines, you can do that as well. There's no problem there.
Okay, so in the top of the file. So even before the requires.
Yeah.
Okay. Before the requires.
And some people like to put the requires first. I personally prefer the provides first because, as I said, it's the module's output, so it's what we're mostly interested in. Yeah, so you want to export the serializable and byteable. You also want to export the predicates from the generics and probably the the predicate the interface descriptors, which are called gen colon serializable and gen colon byteable, because you need those to actually implement the interface in a struct.
Wait, I think I misunderstood. I thought you were talking about the predicates that I just added.
Yeah. You want the predicates, and you also want the gen colon serializable and gen colon byteable because those are the type descriptors for the interfaces. And you need those type descriptors to actually implement the interface in a struct.
Oh, okay. Let's check that out though. So
Yeah, it's the
what you are saying is that we need the gen something something, right?
yeah. See the struct num. It implements printable, but it needs see the this identifier gen colon printable.
Ah, okay, so this is also dynamically generated.
It is yeah, and it's a colon, not a hyphen. So
Oh, sorry. Serializable. A bunch of stuff. You need a bunch of stuff. It would be actually pretty nice to have like, I don't know. I'm not saying it should be a macro by any means, but they should have something like provide all serializable, and all that stuff is already provided.
there might be a helper for that somewhere. I'm not sure it's a default thing. It's probably not. I know there's a struct out for structs, but I don't think there's one for interfaces. But the
Okay.
thing is, you don't always want to do that
No, no,
because
I know, I know, I
sometimes,
know. Sometimes you
yeah,
want to encapsulate stuff. That's fine.
yeah,
But in our specific case, I believe you're gonna have to have all three of them: the names, the predicates, and the gens. What I'm gonna call generators just for the sake of it.
yeah, sure, sure. It's actually generics, but okay.
Generics. Okay, that works. Okay, so now we
Um,
have generics. Okay, that's cool. We have contracts. We are defining that these things need to be like this. That's awesome. These we for every single generics defined, we gain a predicate that is dynamically generated. I wonder if LSP is gonna grab that. I don't have LSP on, as you can see, but that would be something cool to test.
it
Because in Okemo,
should.
the LSP actually grabbed that.
I think it should because Racket's LSP is actually based on code from Dr. Racket, and Dr. Racket definitely gets it, so it should.
Okay. And then we also are exporting a bunch of stuff in the same provide.
Um,
Okay.
by the way, you have some extra ease in the bytables you are providing.
Extra ease. Bytable, bytable, bytable. There's an E here. And there's an E there. Cool.
Cool.
Okay, so okay, that's cool. That's actually it feels better already. So we have this. Uh, we gain predicates. Okay, that's actually pretty cool. That's pretty cool. Well, I shall say that it's cool for a dynamic mindset.
It is.
Uh,
It is.
okay, now we can go. I guess we can go. Actually, we need to change the define serializable now, I guess. So let's go there.
Yeah, we do. We do.
So where the heck? Oh, here. Here's what I'm defining there. Actually, now that I think about it, do we really need to change this? This seems pretty generic, not gonna lie.
Let's see. Define serializable, name body, using a define. We kind of do actually, because the syntax for defining a struct doesn't actually use the define
Ah,
form.
okay, so it used something else. Let's check that out. Racket. Let's go. Let's freaking go. Actually, maybe I should have gone to this one. No, it works. Okay, so it's
Yeah,
actually struct instead of define.
yeah.
Okay,
Oh,
okay, I
and by
see
the
it.
way, yeah, and by the way, you are at the yeah, you're looking at the reference, which is the detailed and more, uh, exhaustive documentation. There's also the guide, but I don't think we want to look at the guide right now because there's even more English there.
Again, I'm not saying I don't like English. I'm just saying that. Uh,
Oh, you're still at the reference, actually. I'm pretty sure there should be a link to the guide at the top of the page, I think.
I don't think what I'm gonna say right now it was recorded back then. But you see this thing here?
Yeah.
That was breaking our compilation.
Why?
I have no idea. I only know that we were having a very, very big an overwhelming session. And the error messages are not great. I'm not gonna lie. I'm not a fan of Racket's error messages, but definitely that one was completely nonsense to the problem. And then something internally within me said, "Man, it's 2023. Unicode is a thing, but I don't trust these people." And then I removed the lambda symbol and I put it lambda, and it worked. And me and Magneto, we were just shocked. Like, wait, this works in a REPL, but it doesn't work when compiling? What do you mean?
I don't see why it shouldn't, but okay, that's weird.
Yeah, it was very, very underwhelming, I gotta say. Anyway, so now we're actually gonna change this guy to entity structs, right? That's something.
Uh, you have to rename the entity classes above to entity structs as well.
Yep. Um, okay. So let's do it then. So now we can go here. Now we can go here. I think that we should start by like just copying the entire thing, and then let's
Yeah,
convert it to an actual struct now.
yeah, struct syntax is completely different from class syntax.
No.
I'm not gonna lie.
I'm not, it's not about the syntax. It's about remembering the requirements.
Okay,
Because we for sure we're gonna forget something.
okay.
Okay. So let's just see the syntax. Okay, so I'm guessing this is the syntax for fields. Like you have an
It is.
author and then the document, and then we have an author, a title, and a content.
Yes.
What about methods though? What
Methods, I think there's an example in the generic interface page, actually.
what
There
is a
might be one
guard
here.
as well?
A guard is actually, I think you're gonna like this. A guard is a procedure that you put on a struct, and then when you call the struct's constructor, it actually calls the guard first with the same arguments that the constructor got, and then the guard has the opportunity to manipulate the input arguments arbitrarily. And if it doesn't like the arguments you pass to the constructor, you can even throw an exception to check to say that, hey, you gave me some stuff that doesn't make sense in this struct. So
Oh, okay,
yeah,
okay, okay, okay. I see the use case of this. Uh,
it's not something you're gonna use a lot. When you
well,
do use it, you don't really have a replacement if you don't have the option to
I
do
think we're
that.
gonna use it a lot, no? Because now that we have this, because if you think about it, our code, this is like one of the most unsafe things that we have done at all, which is the fact that we don't have checks for the fields, right?
No, see, the reason I say you probably won't use it a lot is because you can just put a contract on the constructor and it does effectively the same thing, and it has better error messages. So
Wait, so what's the benefit? Okay, so I'm assuming these two features they were not made together then.
they
One
were
thing came.
not, but there's actually a reason for that. When you put a contract around the constructor, all you can do is check that the arguments to the constructor match the contracts. But when you put a guard in a struct constructor, you can actually manipulate the inputs arbitrarily, and you can even change them.
Okay, so that you're actually saying that the guards provide you power that we are not necessarily willing to give to people.
Yes, basically.
Yeah, okay, that makes sense. Okay, now you convinced me. We should use contracts for that. Okay, okay.
You see,
Uh,
a guard would be really useful, for instance, if we were implementing a fraction type and you wanted to make sure that the fraction is always irreducible. You would do that in a guard.
okay. Um, okay, so let's go with the fields of a type. A type has a name and it has a byte size. It has a byte
Yep.
size. It has a byte size. Why? I'm starting to think. Why exactly do we need from bytes again? Because from bytes is basically doing this serialization, no? What am I
Yeah.
missing here? Received.
It could be that you implemented it that the way you did because it was the only way to do it with classes, but it may be the case that you don't actually need it. I don't know. It could be. I'm not sure.
Yeah, but I think there was a very specific reason.
Actually,
Uh,
I can think of a reason why you would want it. Like for type, obviously you can just look at the byte size field and that's that. But if you have some kind of composite that contains a type and maybe something else, it could well be that the byte size of that thing is computed from the bytes into something else, and it's not actually a static thing.
I don't know if I got what you said.
For instance, suppose I'm just making this up right now, but I
Sure.
think you could think of something similar that could exist in the code base. Suppose you had a list type, like a list struct, that has a type and a number, which is the number of elements in the list. The byte size in that case would actually be the byte size of the type times the length of the list, right?
Sure.
That's something you have to actually compute. It's not a static value just there, right? Which means you would probably want the bytable interface for that.
No, yeah, I think my question is which scenario? Because let's look at both of the implementations. The difference is for the implementations of from bytes and deserialize. The difference that I can see, the difference that I can see. Oh, okay, I do know. I do know. I think it's what you said, but now I got it. So you use from bytes when you know that what's coming it's a byte. It's a type. You know that. And how do I know that? Because you're using the entirety of the byte stream in order to, and then you are checking with the type itself, right? Because this byte size is from the object. So you already have a type, and you want to get another type out of it. So that's why we return news and stuff. This guy is like not, you don't know if it is a type at all. That's why you need to actually deserialize the names and stuff like that. Yeah, I think that was the reason originally. I don't think I ever used it. I don't know if I ever used this ever. Uh, but anyway, that doesn't matter. So we have a name, we have a byte size. Um,
And by the way, there's a cool thing you can do with structs. If you want to make sure that equality works properly, you can get it out. You can get that automatically if you just put the keyword transparent after the fields.
wait, you're saying that when I do the keyword transparent, I get what for free?
Equality, basically. It has to be after the field list,
Oh,
so
after
not
the field
inside of it.
lists.
Yeah,
I
after
thought
the
it,
field
I
list.
thought I thought it would be after each one. Transparent. Okay.
Yeah, because basically when you create a struct and you don't put transparent in it, the default behavior is to create an opaque struct, which is useful sometimes, but it's probably not what we want for this because you may want to compare things like check if two types are equal or something.
Yeah,
And
yeah, that makes sense. That makes sense.
in that case, transparent is very handy because equality just works and you don't have to do anything else after that.
Okay. Actually, I can imagine a scenario in which you want to make custom equality, so you don't make them transparent, and you allow methods. You create methods that will do the custom sort of equality or whatever.
That's
I can
possible
imagine
as
that.
well. That's possible as well.
Yeah, I can imagine that. Okay, now let's go to how do you define the methods for them? How do you define a method? What is inspector?
Inspector has something to do with um, it has something to do with how opaque the type is because it's not actually an all or nothing thing. You can control in a more fine-grained way how the type can be inspected. Transparent just happens to be the most permissive option, but
Oh,
it,
okay. So transparent is a competitor of inspector.
yeah,
Okay.
yeah,
For now, let's
basically.
let's be transparent. That's okay. Later on, we can change it. Likey. I like this. That's cool. I want
Yeah,
the methods though. Methods. Aha.
there we go.
Question then. Is this a generic interface?
It is.
Ah. Okay. I see ya. I see ya.
And you can
Okay.
implement more than one. In fact, you can implement as many interfaces as you like. It's
Yeah, this is a
totally fine to
very
do that.
that's a very Lispy thing. The whole drama and the whole traumatic experience of object-oriented programming languages that doesn't allow you to have multi-inherent, multi-interface implementation. Apparently, Lisps they are all like you can have everything that you may want. We don't care. So Common Lisp, for instance, they allow multi-inheritance.
Yep,
And I
they do.
remember the first day that when Commander explained that to us, and I said, "Wait, isn't this like a big deal?" And Common Lisp already have it. And then Commander said, "Yes."
It's not Common Lisp already had it. It's more like Common Lisp had it since I think it was defined in the 70s or the 80s. I don't remember exactly. And actually, there were object systems even before that that had multiple inheritance in Lisp land. So like, yeah,
Yeah,
it's something
crazy
that
man.
is a very yeah, it's a big deal for mainstream languages, but for Lisp, it's like, nah, this is literally last century.
Yeah, exactly. Like this is exactly the an example of something that everybody's it's a big deal now, but this is already a solved problem. Like
Yeah,
it's
it is.
already solved. Hashtag pay attention to old stuff.
Yep.
Okay, so I'm gonna do the gen bytable first. So my understanding is that we're gonna put from
From
bytes
byte.
here.
Yep.
Then we're gonna put what is the
The first argument, if I recall, is going to be
from
yeah, the
bytes gonna
byte.
be bytable and then byte stream. So I'm gonna put
Yep.
bytable here and then byte stream. And then here we're gonna put the implementation. Oops.
Yep. It's just like implementing a function, no difference
Yeah.
at all.
Yeah, I see. So let's. Ooh, this is a problem. Okay, we encounter our first roadblock here. Let me show you what I mean by that. So this code is not going to work at all, right? Oh no, actually it depends. Can I have access? How does scoping work on structs? Because in with objects you have some very weird rules like you need
It,
to what is the name?
you know
There
how I
was a
said
thing. Oh, this inherent field. So a subclass string of the superclass literal, the literal has a field called value, but I can't arbitrarily call it in the subclasses unless I put this thing. That was really weird. Really weird back when I discovered. So how does that work here?
it's just like defining a function?
Sure.
It's literally just like defining a function. When you define a struct, you actually get the accessors for each field defined together with the struct. So like if you write type dash name, that's the accessor for the name of the type. And if you write type dash byte size, that's the accessor for the byte size of the type. And you can just use them as you would normally.
Wait, so you're saying that there is a notation to use this thing here?
It's it's not even a notation. It's just when you define a struct, it automatically defines the field accessors. And when you are defining the methods, you just use the field accessor the same way you would use them anywhere else. So there's nothing special there
No, I
at all.
understand that, but I don't know. What I'm saying is that I don't know the syntax for the accessors.
If you go to if you go to the top of the page for the struct uh, page, the one you're looking at, Yeah, there's a syntax. Just below the syntax, it explains the additional identifiers it defines.
Name ID?
Ta-ta-ta-ta.
No.
ID, field ID. Yeah.
Okay, so for each field, an accessor procedure that takes an instance of the structural type and extracts a value for the corresponding field.
Yeah. So in this case, it would be type dash
Type
name.
dash dash. Yeah, but you need to put type twice.
No, 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 you don't. Because there's
Oh,
the
this
field
second
ID.
ID is the field ID.
Yeah.
Oh, okay, I see. Okay, so what you're saying is that I just do this.
Yeah, type byte size is actually a function. It takes a type and it returns the type's byte size. It's
Okay, so if it is a
literally that.
function, what do I pass to it?
The byteable, which actually would be a type in this case because it's, you know,
Oh, I understand now. Wow, that's actually a very weird. Actually, it's not that weird. It reminds me of Rust now.
you
Because
see, the
in
thing
Rust it's gonna
is,
be like self.
yeah, you can totally just write self there and use it like that. There's nothing stopping you from doing that.
Am I gonna go to jail because of it though?
No, I
Okay.
do it all the time, man. I mean, naming things is hard, so I like to avoid that as much as possible.
Okay, okay. Next question. The from bytes actually needs to return another struct. No, right? So how do you create a type? How do you create how do you create stuff?
You just
Define. Is that how you do it?
no, you just use the struct name. That becomes the name of the constructor, and you
Oh,
pass
okay.
the arguments positionally in the same order you declare them. That's it.
Oh, wait. Wait. I remember now, man. I'm so freaking dumb. I completely remember why we need the from bytes. So what this is doing is the following. Let me explain. Let me freaking explain. So let's suppose that you have a type, right? Let's suppose that you have a type. And you want, and you have some bytes, right? And you know that the contents of the bytes is a literal, right?
Yeah.
Is a literal. So if you want to have a value that you know it's type already, but it's in a byte form, you call this from bytes. So that explains it because what look at our return type. We are returning an integer 32 object, which means that we are returning a literal.
I see.
So the reason why this is possible is because there is an intimate relationship between the types and the literals. Because it is assumed that every single literal has a type.
Well, if you want to do it like that, you can actually get rid of the type struct entirely, and you just define the different literal types, and then the struct type descriptor itself becomes the type you were interested in, right?
Oh, you're saying that instead of having like we could have multiple types, like a type for integer, a type for whatever. Is that what you're saying?
No, no, you just define struct integer, which I'm assuming you're going to define at some point, right? Because you have integers.
Yeah, we need the integers for literals, yes.
You get rid of type entirely. You just define the integer struct, and then inside the integer struct, you define the gen byteable, and you say from bytes of the 2 byte size actually of the integer just returns a constant, which is however many bytes an integer takes. I'm going to assume
Yes.
it's 4 because you say
Yes.
integer 32 there, right?
Actually, that's not let me think because that will. My feeling is that your strategy is gonna cause some redundancy. Let me think about that. Just to be clear, what you're suggesting is actually to remove the definition of a type and
Yes.
just put the type information within a literal.
Yeah,
Ah man, this is the type of stuff that Mageta would be very helpful because he knows the implications of that during the entire process. Because you gotta remember, we did the entire serialization based on the previous stuff.
I see.
Mm,
Yeah, I mean, what I'm describing is the natural way to do it following Racket idioms. But yeah, I don't know how well that matches with the design you're following, so I cannot comment on that.
I'm gonna say I'm gonna say that we're not gonna do that because sometimes you want to handle types themselves, and it doesn't make sense to carry an entire integer because we don't care about the integer itself. You know what I mean?
But you no, but what I'm saying is you don't actually have to carry an entire integer because when you define a struct, you get a bunch of identifiers. One of them is actually called, I think it's called, let me check. I think it's called struct colon and then the struct type. And that identifier is basically a type descriptor for the struct. So you already have a type kind of built in. You don't need a
Let us say that I want to have a varchar. Okay, I want to manipulate a varchar type. I'm gonna have to
sure.
create a struct of a string in order to use a type descriptor to get the type out of it. Am I following that correctly?
You have to define the string struct at some point because you want to have strings, right?
No, no, no. We're gonna
But if
have
you
to
just
define strings
but
at some point, that's for sure. But that's not
but
the
if you
question.
but if you just want to manipulate the type itself, you don't have to build an actual string. You can just take the struct's type descriptor.
What the type descriptor gives me?
It gives you all the methods you defined. So you can use it as if it were an instance. Obviously, it isn't. So if you try to access the fields, it will fail. But if the thing you're doing doesn't actually need the fields, for instance, if you just want to check the byte size of something, the type descriptor can just do that just fine.
Okay, so actually let's try. I think that's going to completely blow up the serialization, but I don't care. Let's say that this is an integer 32. Now,
Okay.
now we need to change some naming here. So this is going to be the type name, right? So we also going to have a value here. Type byte size.
Question, why do you need the type name?
Because those two things are not the same thing. Like as you noticed, we have strings, but we don't call them strings at all.
Oh, I see. That's fair.
What else is important in a literal? Let me go down here. Okay, so this is all a bunch of stuff in order to have prints because, well, that's the effort that you need to do in Racket to have prints.
Yeah,
Uh,
printing structs just works if they are transparent.
yeah, pretty cool. Okay, so what you have in this, let's go to integer 32 because integer 32 is a lot simpler than in a string. So we have serialize, we have deserialize, which is we're gonna already do anyway, and we need to have a field value, and anything else is completely okay. Okay, so I think we can go with this approach. Let's see what changes because now we are kind of inverting it. Before we were completely separate. We have types and we have literals and they communicate together because
Oh,
from using the from bytes.
yeah.
Um,
Here's an
using the
idea.
go.
Sorry, I just ideas channel, but so here's an idea. What if type were a generic interface as well?
What's the benefit of that?
You don't need to get a type name and a type byte size as part of the values stored in the struct. You can define them as methods, and then
Okay, okay.
if they happen to be constants, they will just be constant functions, so they don't actually take any space, which means
The,
it's more
some of
efficient.
some of them will be constants. For instance, the byte size of an integer 32 is always going to be 4.
Yeah.
Uh, that's not a bad idea. But it's gonna be a little bit cursed because the name that we're gonna use is the same as Haskell's name, uh, which is cursed. So let's go. So we're gonna have typeable. It bothers me a little bit that typeable has the e
No,
and the
I mean
byteable doesn't. Okay. So what, as a type, what do you need to have? You need to have a name.
You need to have a name.
You need to have a name. So this is gonna be typeable. We're gonna make the contracts for that later. What else are we gonna need? We need to have a byte size.
Do
Byte
you?
size.
Isn't biteable just doesn't biteable already give you that?
Oh wait. We have a problem.
What
Strings are
problem?
dynamically sized, right? Strings are
Sure, but
dynamically sized. How the heck are we gonna how we if you're not gonna store the size of the string, where the heck are we gonna do that?
that's a good question.
Because integers they are like a very simple thing on the number four all the way through, but when you have strings, we don't know before runtime what is the size
Uh,
of it.
well, luckily, 2 byte size is a method, so it's actually a function, which means you can put arbitrary code in it. So
What do you mean?
that's that's the thing. 2 byte size is a method, right, of the byteable interface.
Yeah, but now we need to make separation of concerns here, okay?
Okay.
Uh, Wait. Let me double check a thing before I say what I was about to say. Does a string receives a type? Yes. So they are always the same. So we don't need this thing. Go on.
And then when you go to implement the struct for strings, you just have to replicate whatever implementation you have for the byte size currently in the interface implementation,
When I'm
right?
gonna define.
Because right now there's already an implementation in the class-based version of the codes for string size, right?
Yes. Yeah, but it's kind of cursed. Yeah, it's not cursed because it was made by design, but when you serialize a string, you need to know its size, and only the type has this information, right? So you actually send a type to the serialization thing.
I see. Uh, and how do you get the size of the string then? Like if you try to call 2 byte size of the string or the string's type in this case, right?
No,
What?
this is not a
How?
type. That's the thing. This is not a type.
It's not?
This is a literal.
Oh, right,
Be-
right,
be-
right.
because like the type actually stores metadata, right? So you have a varchar of 5 bytes. You don't know what is the string in the 5 bytes. You just know its metadata, and the literal itself, which has a value field, knows its content, and it communicates with the type to know to do truncation basically, right? Because if you have like if you try to have a value of 20 characters, but the type that you made is only 5 characters, we need to truncate that, and this is
I
exactly
see.
what this if is doing. And
Well,
the opposite is also true. If you have less data than what the type size demands, you need to add padding to it.
I see.
Um, but I'm still interested in what you said before. You said that when I'm creating a struct, I'm gonna do something that it's gonna store, that's gonna store the size anyway. Go on that.
Um, right. What was I saying? Basically, you're defining currently the integer struct, right?
Yeah, we're defining the integer struct here.
Right. And its size happens to be a constant, right?
Its size happens to be a constant, yes. So when
That
I'm
means
gonna
you don't,
implement the 2 byte sizes, I'm gonna return const4.
yeah. That means you actually don't need a field to store the byte size, do you?
In the case of the integer, no.
You don't.
In the case of the integer, no. But what I'm concerned about is actually the varchar, because the
Yeah, for the
varchar.
var, yeah,
Oh,
for the varchar, um, One thing you can do is you can store a size alongside the contents of the varchar, but then that limits you to having a varchar to know the size, right? That's a problem.
Yeah, that's a problem.
Hmm.
Yeah, that's a problem. Exactly, that's a problem. Like I don't see. Maybe I'm missing something, but I don't see any other way in the case of the string to do that. And because the string does have need to have it, I think we should be consistent in having both places. And if that's the case, we can actually remove the constraint of 2 byte size, for instance.
Sure.
Actually, now that I think about it, if you're gonna fuse the type in the literals, we don't need from bytes anymore, right? Is that right?
Why not?
Yeah, because the from bytes it was doing a conversion. Let's take a look here, down here. So you already know that there is an integer, I don't know, 23 inside this.
Okay.
So what do you do? And again, this is completely regardless if I'm actually using this because I'm pretty sure I'm not. From bytes. Well, this is probably happening. Oh, there is a one guy using it. Oh, okay. Actually, this is exactly what I'm talking about. So, see, we have a type that we already know what it is. So we know it's a varchar, we know it's an integer. And we
I
know
see.
that the following bytes is a literal of that type. We know that.
I see.
So then we just ask, go to the varchar and deserializes for me the string.
I have a question actually. When you serialize a string, uh, does the size of the
Go.
string get stored anywhere?
Yes, it goes with it.
Well, in that case, the this might be a little bit cheaty, but you can have a string struct, no need for a typeable thing, and then the string 2 byte size, it but 2 byte size doesn't actually take as a string, does it?
No, no. Well, it theoretically takes the thing itself, right? So
Yeah, it just takes
in
the.
theory, you can have the value of the string because you have the entire struct, right?
That's the thing. You don't necessarily have the entire struct. You can call the 2 byte size with the struct type descriptor. That's possible.
I
That's
need to see this
effectively.
type descriptor thing on the screen because for me it's getting confusing. But go on, go on. You were about to say that we don't have to store the string size because
I mean, if you have the bytes that you're parsing, and you know that you're going to see a string as the next literal in the byte stream, and we also know that the byte size is part of the literal in the byte string, we can just look at the byte stream and get the size from there. Is what I was going to say.
no, but
But
that's
then,
only the other way around. You are thinking how we're gonna get the data back from bytes, which is okay. We can just read it and who cares? That's okay. But that's not the problem. The problem is the opposite. You have on memory running your program. You have a string, and you want to you want to to serialize it.
oh, you already have a string and you're trying to serialize it. I see.
Yes.
Now, in that case, you can just call string length, no?
Uh, I think it really. I mean, I think I'm getting even more confused because because I need to see the type descriptor thing because we need to think about it. The schema doesn't have any values, right? The schema only has logic, which means that it only has types and metadata, right?
Okay.
Within a type, within a type, we need to be able to say, in the case of a string, how many slots you have available for that specific table.
I see.
How we're gonna, so we don't have a string at that point, right? When we have the schema and we create a table, logically, you don't know how many, you don't have a string with you at that point. But you need to save the information that this column has this type that has the size X. But
I see.
you don't have the content with you at that point because you're creating the table.
I
And
see. Well, so in that case, yeah, I think fusing types and literals in this case is not gonna quite work because you actually need to have a value that describes a type, right?
yeah, no, but you said something important before. You said that with a type descriptor you can obtain such information, right? My understanding is that a type descriptor is like a substruct of sorts. It gives you
But
data that you can accumulate somewhere.
a type descriptor is like, let me see if I can explain. I'm going to cheat a little bit and appeal to OO stuff. A type descriptor is basically a class.
But if it is a class, we can. That's going to be a little bit cursed, I guess, because how are we going to describe a table having fields in which a field has a type descriptor? Is that a thing? Can we do that?
You totally can.
Okay, let
I
me
mean, it's a
actually show
value
you
like
that.
any other. You can just use it.
So a table, let me go down here. A table has a bunch of fields, which is another hash map, and then a field has a type. A field has a type. And this is the
Field has a type.
guy that has the size information for strings.
I see.
So when we create the field struct, we're gonna have to have a position to know which column is the first, the second, and so on. And we also need the type in order to say what it is, if it's a varchar or an integer, and how many bytes we should allocate to it. Like we should do some sort of validation in this sense. Can we
Yeah,
put a type
that
descriptor here?
you can. You totally can.
Um, okay. I'm starting to get a little bit worried because now it seems that the design is getting more complicated now. Because now we are
Yeah, no,
fusing two entities.
yeah, no. I think it might be a good idea to go back and just say there's a type struct, and the type has the size and the name, and we just accept the fact that structs are that types are values. We are dependency type now.
Yeah, that was actually like when we did this first thing. I discussed with Mageta like, man, how are we gonna do this? Because with ADTs you can just do it because it's very easy to do it. Not in the sense of dependently typed, because this is not actually still dependently typed because we're not checking anything. There are no constraints in terms of values being made. We are just accumulating values along the way. That you can also do that in your Camel and so on.
Sure.
Um, but then I asked, like I remember, like Magetta, how are we gonna do that, man? With like more than an OOP, I think we're gonna have to use a class. And then he cringed a little bit because it is supposed to cringe everybody that now when you think about it, like, wait, a type is a class? What do you mean? But that's how that's how we did it. What do you mean? Okay, so let's go back. So we're gonna have a type, a name, sorry. Let's actually
And
remove the extra
yeah, it
class
will have a
here.
size. Yeah.
Okay. Um, a name, a type, byte size. Is that it?
Yeah,
Yeah.
you don't need a type in front of the byte size. Yeah.
And then we need byteable, which is already what we are doing here. And for the time being, because we don't have these structs yet made, I'm going to return 0 and 1. And then I'm going to put
Will
to
do
do.
fix me.
Oh yeah, in Lisps you guys prefer these, right? So change these guys to actual structs of literals. Okay. Okay. Okay, so this is done actually. So now we can go to the next one. So the next one is 2 bytes. 2 byte size. I don't know if this is gonna work, but I'm gonna do it like that. And this is just gonna return type byte size.
Yeah, that's not gonna work.
Sad.
What you're doing
Uh,
there, what you're doing there is you're taking an argument which you are ignoring, and you are returning a function that happens to be the accessor for the byte size of a type.
oh yeah, I forgot. I forgot about that. I forgot about that. I need to put my mind that I'm doing Rust. That's gonna help me. Okay. Okay, that makes total sense. Next one. Actually, now I think we are done, right? So this is that. Do I need to add another special syntax for other methods? Like I need to copy paste all of this to make another interface?
You need the methods with the gem. It's serializable, right?
Yeah, but can I accumulate them like this?
No, I don't think so.
Man, I don't
It,
understand. You guys love
that,
macros and stuff in syntax manipulation, but you don't love like convenience stuff.
no,
Ah,
there's actually a reason for that. You see, it has to do with scoping actually, because for each interface, the struct macro creates a new scope where a few names are treated specially, the method names, right? And they become the method implementations. And then you actually have a scope between the square brackets in pink there, where you can define as many helpers as you want, and they will be visible in that scope of that particular interface,
no, I
but it doesn't
understand. I
discount.
understand
Yeah,
that you're gonna have to add more constraints to it. Like you're gonna have to disallow helpers that would have the same names if they were in different scopes. That's fine. But the thing is, if I'm aware of that trade, what I'm trading with, and the whole, I'm gonna say the whole point, but a major point of the language is literally bending syntax. Why
it is.
not allow me to do
You'd have to ask the people who designed the struct form,
it?
because I don't know.
Okay, so now we're gonna delete all of this. It's so interesting to see how different it's gonna be. So let's grab this because you're basically doing like a surgery. We are surgically changing the removing stuff from the object and transferring that over to the instruct thing. Okay, so
By the
this is a
way,
function, so we're
uh,
gonna have to do type name. Go on.
I almost never use let star in Racket, actually.
Oh, I use all the time.
I don't, because you can do the same thing with internal defines,
Yeah, you
and
can.
it has less indentation in that case.
Yeah, yes, you can. But you need to remember that I was trained in Common Lisp.
Right, right.
So this is gonna be type. Oh no. Actually, this is what we created in the let there. What is the other thing? Are we using anything else? Let me check. Byte size, name bytes, length. Okay, we're not using anything else, I guess.
Here, the byte size you're using in the integer to integer bytes
Oh,
over
here.
there,
Yeah.
you have to replace it with the
This.
is
Is
yeah,
this the name? Yeah, that's
it
the
is
name. Okay, serialize. Done. Next. Um,
deserialize.
wait. I think I messed something up. Oh no, it is in here. Okay. Deserialize. Okay, so deserialize, it takes two things and the byte stream. I guess that's how I call it. Yes.
You know,
So
you might
let's.
think this is. you might think this is not a good idea, but I'm just gonna throw it out there. Um, what if one of the fields for the type is actually a struct descriptor, and you kind of piggyback on that to deserialize stuff? Is that something that makes sense?
I don't know because I'm not too familiar with type descriptors at all. I have no
No, the
idea.
idea is no, the idea is you want type descriptor specifically so you can use the generic methods implemented by the type that you are dealing with. Like, I don't know, it could be that I'm just thinking about something that doesn't make sense in this context, but
I have no. I can't tell you because. Let's do the following. Let's try to do the most naive way first. In the way that makes sense. Like for instance, all of this is not naive, but it makes sense. This.
okay.
And then let's change the design. And then when things start to arise, because if we try to do the opposite, which is kind of like the top-down approach, let's think of all the possibilities, and then let's try to implement it
Yeah,
correct first.
no.
We would go to the conclusion that we need Magetta, and he's not here.
No, let's do the falling rain strategy. Let's not deal with trees. Trees are cursed.
Okay, so that's it actually. The serialize. Is that it? Do we have a type? No.
I guess. Let's just double check if you didn't make any syntax mistakes. Let's see. Make bytes, bytes ref, byte string, name length. Name length is something you computed over there, so that's fine. The bytes of the byte string. Okay. Oh, you're doing set type name and set byte size, right? That's
Yeah,
not a
that was just
thing.
a guess of the syntax. I need to check here.
Yeah, no, in this case, you're actually going to build a type, so it's just type and then the name and then the size, and that's it.
Oh wait. That's
You're doing mutation there, right?
yeah, we are doing mutation, but now I need to think about it because
No, you just
the no
build the type. You
no no
just build it, man.
that's not true because you're thinking that you're gonna return that, right?
Yeah,
That's not true
why?
because remember, the serialization always returns you the amount of bytes that you consumed by
You
design.
can, well, that's gonna have to change because, I mean,
Yeah,
you
now
can,
that I'm thinking about it, like the entire mindset of serialization was based on mutability, and now
it's
I need to
not.
think
So
about it.
in this case, it's fine. You just return values and then you return the value you deserialize, which will be a type you're gonna build right now. No mutation, just call the constructor. And then you return however many bytes you consumed, and that's that.
Wait, I'm confused. Can't we do what this is doing? Set cell content here. Is this producing a new
That's
one?
that one is not, but you see that in the struct definition, 2 lines above, the content is defined as mutable.
Ah, it's mutable. Okay, let's not do that. That's completely good. That's completely. It's gonna completely erode everything.
No, we can just adjust the deserialize contract and say it returns multiple values. It returns a deserializable and a natural number, and that's that.
Okay,
And then we
so
just
how do we do that then? Are you saying that we're gonna do deserialize instead of doing serializable? We're gonna
yeah, you
return.
just open parent values. There's a contract for values, and I think it's called just values. I could be wrong. Let me double check. Function contract. Function contracts. Yeah, it's values, and then you just put the serializable and a natural. Yeah, that's that. It's just that, literally just that.
Okay, and in
And
here,
then
what do we do?
you call values, and then the first value you return will be the type. So you just build the type with the name and the size.
How do you do that? It's like type, and then it's positional, right? So I need to have the
It's
name,
positional, so name and value,
name
name and size.
value, and then size value. Okay, and then I put the other thing here.
plus 5 name length. Yeah,
And then that it is what it is.
it is what it is. Yeah, that's that.
That's gonna explode there, all the serialization, man. But okay, we're gonna have to I'm gonna have to fix that later, I guess. Is that it?
That's it.
Is that it?
You wanted to get away from mutation, right? This is a language that's built around avoiding mutation, even though it allows mutation because it's a list,
Let me
right?
be more clear, right? I do prefer immutability all the way through, but there are a few key scenarios in which the case that we are right now is one of them that I would be okay with mutability. The first thing is performance concerns, right? So in the beginning, you may lose referential transparency because of mutability and stuff like that, but then depending on the language, you can actually regain the referential transparency based on something else. So Haskell has the ST monad that allows you to do just that. You can retrieve the referential transparency, but using mutation still. And
Yeah, I can tell you right now that for this particular method, building the value is not actually a performance concern. Because if you look at what you're actually doing, you
no,
will
no, no.
notice
But
that
this
you
is not the
never.
case. I didn't finish.
Okay,
Our case is the second case, which is when it's you have already some infrastructure that was made on top of that. So this is a very silly example, but let me tell you a more real world example that I personally experienced. So most CI systems, they are very mutation based. And I participated in a process in one of my previous jobs of doing a migration of one system that is completely based on mutation, a CI system which is called Jenkins, and I participated in the team that would migrate that to another CI system called Concourse. And Concourse has immutability in mind first.
I see.
And that whole experience, it took a lot of learning curve and a lot of extra learning extra stuff because the entire side of Jenkins was completely from the ground up based on mutability, and we had to think creatively how the heck are we going to do that if there's no shared global state in Concourse. Um, so I'm not saying that you shouldn't do that. I'm just saying that you should be aware that if there's already infrastructure built on top of the idea, you need to try to do the math to see if it's gonna worth it in terms of costs and time and labor, all that stuff. In our particular
I
case, we do have infrastructure. We have an entire file based on the fact that all the deserialization all the serialization processes are mutation based and they return only a single value. But I am willing because we already settled that we're gonna go this way because it's getting too much complicated to do the other way around with the objects. So I'm okay with changing it, but I'm just explaining my thought process.
That's fair. That's fair. By the
Um,
way, a
Go.
fun thing. You see, I was going to say this serialize specifically doesn't actually fall into the performance concern because
Yeah.
if you look at what you're actually doing in there, you're never actually touching the self, right?
Yeah. No.
That means that means the self doesn't actually have to be an instance of a type. It can be just a type descriptor of a type, as in struct colon type, you know,
Mhm.
and that works. And it's basically a way to get to cheat in return value polymorphism because that doesn't really work.
Hello. Hello. Marinho, are you there? Hello. Hello. Ah, Marinho.
Oops, hello.
Okay, now
I
you're
got
back.
disconnected for a moment there.
Okay.
And
Uh,
anyways, as I was saying, this is a way to cheat in return value polymorphism because in Haskell that works because type classes are statically typed, right?
yeah.
So if you see that the return value has to be a particular type, you can call the correct instance based on that, but that doesn't work in a dynamic language. So what you do instead, you pass the type as an argument. In this case, would pass the struct colon type, right? Which is the struct type descriptor for the typed struct. And then that tells you what the return value should be, right? Because of the contracts we declared.
Oh, okay. So actually, you're using the type descriptor as a hint.
Kind of, yeah, you can think of it that way.
Okay, that's actually it is cool and weird at the same time. Yeah. Okay.
I mean, as I said, return value polymorphism doesn't really work in a dynamic language because, types are checked at runtime, so you don't have a way to know ahead of time what the return value should
Yeah, yeah,
be.
yeah, yeah. No, no, no. I completely understand that why it is what it is. I'm just saying that the idea of having a hint is weird. Uh, anyway, I guess we're done. We made a type. We completely converted this into this.
It was less painful than you expected, right?
Yeah, the fact that we can just swap the names and actually field just became functions and stuff like that. That's actually pretty nice because that means that we can reuse most of our implementation. Assuming again, we are trying to have the least amount of rework and refactoring. That's why I'm not going full blown. I think it's preserve, the thing that you mentioned before, that does
Yeah.
serialization and stuff like that.
Yeah,
Um,
no, that would be a whole another can of worms. It would be a lot of work because you're basically replacing the entire way you do serialization, right? No, that would be a lot of work.
I think that would not be that much of work because it's not like this. Like if you take a look at like how many lines is this? It's less than 200 lines, right? For a custom serialization. So it's not that big of a deal. It's fine. The only thing is that I think that for us, because that's another thing, I didn't have time to study how preserve does things because I don't know which properties I can. I know which assures me. I don't know what are the trade-offs. I don't know if it does partial loading. I don't know a bunch of stuff about it. So my initial intention is okay. We have a big change to do. We want to change the serialization and we want to change the entire abstraction. Instead of using objects, we're going to use all structs. We can tackle both at the same time, and that can be
Yeah.
a little that can be faster, but we are running the risk of being demotivated because that's a lot of rethinking to do at the same time.
Yeah, no, let's take the falling rain approach and do one thing at a time. I
Yeah,
think that's
one thing at a time, because then and first the first benefit of doing one thing at a time is that we're gonna understand a major roadblock faster. Because let's suppose that we dedicated 2 weeks reading Preserve, and then when we actually go to do it, we discover that oh there was a major flaw that was an oversight, and now we don't know if we can use it, and then we quote unquote I'm not gonna say that we wasted a week reading it, but we definitely didn't have code written. And if you do it one thing at a time, you're gonna have some code written. So for instance, we have this type thing written, and we according to the limitations and the advantages that we saw writing it, which we keep changing the retroactively changing the things before. So that's the main benefit of doing
yeah.
one thing at a time.
Yeah, and we already know for sure that we'll do the struct thing. We don't know for sure that we'll do the preserve thing. It's an
Exactly,
option.
exactly. It is an option, and we are open to it, but it's not for sure at all. Especially because I think that it is a little bit, it is kind of cheating if you ask me, because you're gonna do a database. You're gonna use a
Yeah.
third-party library to do serialization,
Yeah.
and you're gonna use a third-party library to do the server and the client stuff. Like,
Yeah, that is kind of cheaty.
yeah, you're cheating the game, you know? I'm not saying that it is the most pleasurable experience to do serialization. I complained a bunch about it because I was the main developer of most of the code. Uh, but it's like I said in the Racket server. It's almost like masochism. It's painful, but it's kind of fun at the same time. Discovering the bug with the this thing, like discovering that this was a bug, where this, discovering that this was the bug, that was not fun at all. It took me hours of sleep thinking about it, the indigestion time, to understand that. Oh, okay, I see. Mutability. I'm gonna write about it actually. I want to write a post about it because this is so in surgically on the point of why mutability should be a red flag. It's exactly because of these type of problems that I had.
Yeah.
Going on. So let's now make the struct of as integer actually because it's faster and it's already 2 hours. So let's copy this because I think all of them. Yeah, I think all of them are gonna have to be. Oh no, this doesn't have to be biteable. Uh, okay, so this is gonna
I
be
mean,
an
it can
integer.
be. It can be because,
No, but it doesn't
it's
make sense
pretty
to be
easy.
biteable because the semantics of from bytes is gonna be weird. Because
Why?
from bytes assumes that you have a type and you want to create a value out of it. We are already in the value struct,
No,
right?
you can just pass struct colon integer 32, the struct type descriptor, as the first argument from bytes, it will act as the type hint, and that's that.
I guess you can do that. Yeah,
You
I
totally
guess
can.
you can do. I guess you can do that. But for now, I'm gonna remove it just for the sake of simplicity because we're not gonna use it anyway.
That's fair.
But you're right. You can pass a hint there, and then you actually can have both ways working, right? If you have an integer and you want to create another integer out of it, I guess you can.
Or if you just have the integer type, struct colon integer, that works too. But yeah.
Um,
Um, by the way, integer, it should only have a value, right? No name and byte size.
oh, sorry. Yeah, it should only have a value here. Okay, next. We're gonna do this. Grab that. I'm gonna have a really hard time giving the title of this thing. At the beginning, I thought about giving the title we we surrendered OOP, but now it happens so many like now we are doing different so much different stuff that I don't know
No,
what I'm
but
gonna
if
call
you
it.
think of, no, as I said, this is still OOP. It's just it's racket style OOP rather than, mainstream style OOP.
Yeah, but that's kind of what I mean. I wouldn't in a million years guess that an average developer would look at this and say, "Oh, this is OOP," because his
It
first
is,
question would be, "Where is the inheritance going on?" And then you're gonna say, "There
there is
isn't."
actually a, no, there is actually a way to do inheritance with struct, but it's not used very often. Yeah, the serialized self is actually wrong. You need to take the integer value of the self
Oh yeah,
instead of
that's
the
true. That's true.
integer
Integer
32.
value or out of self. There. It's gonna be this and 4. 4. Um,
Integer 32 or
okay, so it's gonna be integer 32, and then instead of all of that, it's gonna be all of this.
that's that, I guess.
And instead of byte array, it's gonna be byte string. Which, by the way,
That's it.
reminds me, I should mention that the way that I am, because if you think about it, like let's suppose that you are programming in C and you have a file pointer. The file pointer will be your way of, in a mutable way, you're gonna traverse the string of data.
Yeah.
We are not doing that, but we are also not doing in an immutable way, because look at that. We are not mutating the byte stream at all, but we are consuming, and instead of doing local mutation and returning the remaining byte stream to do like sort of like a deserialization composition, we are returning how many bytes we consumed, but we didn't touch it at all. Which means that it's up
Yep.
to the caller to take notice of this number here and do the appropriate uh, slicing
Yeah.
of the
This,
byte stream.
yeah. This. We're doing it this way because it was already that way, and we're just doing a translation.
Yeah,
You could, if you want, do the sub byte string inside of the deserialized and return a different byte string,
yeah,
but that would involve potentially a location if you're doing it in an immutable way, or we'll go right back to mutability, which is what we're trying to avoid.
yeah.
So
And
I
I
think we
don't
can.
remember anymore the reason why I decided to go this way. I think it emerged naturally when I was creating the functions. I said, man, I need to slice this, but I don't know how many bytes this guy consumed. Okay, so I'm just gonna say that every single deserialization.
Returns the bytes you consumed.
Actually, now that I think about it, it is more in towards mutation because I'm doing the sets, right? So um, the reason why we are doing values is because we're not doing this anymore, and we are doing this. But this so we improved half of it. Half of the design has been improved because before it was returning how many you consume, how many bytes you consumed plus mutation. Now we swapped the mutation to immutable, but we are still returning how many. So when we do the full translation of the I/O, we're gonna understand how and if there is an easy way to just do, I don't know, I guess it would be like the proper way to say it would be a state moment of sorts, because we're always going to return the new state also, which in this case the state is the byte stream. But well, let's see. And it's that. That's it. That's completely done. Uh, okay, so which I know we're not going to do the table today because it's too big. Let's do the field next, and let's call it a day. It's already past 2 hours.
Okay,
And I hope you're having fun. I hope.
I am actually.
Uh, okay, so this is gonna be field. What does a field need to have? Position and a type. So let's go position, type. Okay. So this is only what is oh, this needs hashable. Okay, forget about it. This
Yeah,
needs
no,
hashable.
that's gonna take a bit of work.
Yeah, that this is gonna need to do the interfaces that you can provide the for implementations. But we need to discover how to do that with hash maps because they are not like strings or numbers, which are the like full-blown primitives. Probably there is
You
some
can just
mixture.
remember I said you can use an arbitrary predicate for the default. You don't have to be necessarily a built-in type. That's kind of the
Yes.
intended way to do it. You don't have to be. You can just put hash question mark and that's it. You're done.
Okay, so we're gonna basically do that.
Actually, I think hash question mark doesn't quite work because if I remember right, that one is for immutable hashes.
Oh yeah, unfortunately, well, I don't know if it's fortunately or not, but
No, it's not. It's
Racket,
not. It's generic. It's generic.
okay, nice. But Racket has a lot of separation in this regard. They have weak hashes, strong hashes, immutable hashes, mutable hashes, and so on and so forth. And you need
And
to
there are
actually have translations like adapters
actually
for those.
it's worse than that actually because each equality predicate has a different hash type, both mutable and immutable associated with it.
Yeah, we're gonna have to pick one, and I don't know which one we're gonna use. I think we're using mutable right now because it kind of makes sense. If I want to redefine a table, I just mutate the value related to the key, and who cares? But anyway,
Um,
so today
oh,
what did we do? We learn about structs, we learn about contracts, we learn about
generic
generic
interfaces,
interfaces.
which
This
are
is cool.
awesome.
This is cool. Even being at runtime, I think it's cool.
And actually, fun fact, you know typed Racket, the Racket
Yeah, yeah,
language
yeah,
that does static type checking?
yeah.
It actually uses contracts to interface with dynamically typed code. So it's
I have a
completely safe.
question
Even
then.
if you...
So, like when you say that typed Racket is using contracts to do the static type checking, my
No,
f
I don't mean that. What I mean is it does the static type checking internally, but then because it's in the Racket
oh, okay.
ecosystem, it will inevitably have to interact with dynamically typed code. And in that interface with dynamically typed code, it uses contracts to preserve the invariants from the static types.
Ah, okay, okay. That's kind of complicated though. You need to like handle cases that are not like I want to say it's not that it's not natively supported because the typed Racket is still a subset of Racket anyway. Not a subset that is smaller, but it is within Racket still within Racket's boundaries anyway.
Yeah.
And then you have a completely different philosophy, but you need to interrupt with both of them. That sounds like a lot of work.
Yeah, there's actually a lot of interesting research coming from that because, there's a lot of things you have to think about when you have to interface static types with dynamic types. And Racket is kind of the pioneer in this area. Like a lot of other gradual typing systems actually are actually based on stuff that came out of typed Racket.
Mhm. Yeah, that's pretty cool. That's pretty cool. And I remember that I need to change the name of that. Okay. Okay, I'm gonna continue doing this translation here with the ones that for strings and so on and so forth. I'm not gonna do that right now because right now I'm just exhausted. And then next time, maybe even during the weekend, we can try to understand how you're gonna try to grab most of the functionality of Hashable as possible. Because if we have like my nightmare is that we're gonna have to copy paste this code a bunch of times. This code
um,
specifically, and this one, these two, and they should be completely generic. So I want us to accomplish that.
I have a small question. What does Hashable actually depend on? Obviously, it needs the serializable interface, right? So we need
What
serialize and
the
deserialize, right?
original idea is the following: we want a class that is gonna well, we don't want a class at all. We wanted something else. But if you want to use a class, if you want to use a class, we want the original idea was to have constraints. So in this case, is via the serializable. But this class will not implement them at all. Would be abstract methods. And then the subclasses would gain these two public methods from the superclass, and because they would implement the abstract methods, the methods that they were inheriting would work because both of these methods assume that you have these implemented, otherwise it's not going to work at all. So it's using the serialize here and it's using serialize here.
I see. So basically, you depend on the existence of those two methods and nothing else. Is that correct?
Yes. Yes.
In that case, it's actually pretty easy. You just have to define a function, a regular function, that uses serialize and deserialize, and you're done.
No, 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 no. But that's the thing. In our use case, it's going to work because we're only going to use that function with things that implemented those two things.
No,
The
but
idea of having the hashable is to have the constraint being valid, the validation being there for us. So,
that's the fun part. You just use a contract for that. Just put a contract that says the argument to hashable must be serializable, and you're done. You can
oh,
just assume,
you mean saying like this, right?
yeah, like that. And because
Ah.
serializable forces you to implement both methods, you can rely on them being there, and that's it. You're
Yeah, right
done.
now this is gonna fail miserably because the serialize just changed. So this is not
Yeah.
a number anymore.
Yeah.
uh, but I see what you mean. I think actually I see what you mean. We're only gonna make contracts of these two functions. These two functions will be completely loose, uh, not bounded to anything. But we're gonna make a contract on them to force to the thing to have to be serializable. Yeah, that's gonna be the way. That's gonna be the way. So I think I'm gonna try to do that by myself during the weekend
Okay.
to try to translate all these tables, and then after this is done, I think I can follow the error messages to fix these things.
Okay.
Uh,
All right then. If you need any help or you have any questions, I can probably answer them. I don't think I'll be able to answer them on Saturday specifically because I have plans, but
okay. You have what?
I have some plans on Saturday.
Oh, plans. Okay.
It's actually a friend's birthday, so
No, no, no. Sorry, I don't want to um, get into too particular details of what it is you're thinking. It's completely private. But I
yeah,
heard
no,
something
no.
different, and that concerned me.
No, no, no. I have some plans.
Yeah,
Like I have
heard
stuff
I
to
heard you
do.
say that you have a poly dance.
No,
I
that's
don't.
not
And
it
then I
at
said,
all.
wait, wait, wait. What did you just say?
Yeah, no,
Okay, that'd be
no.
weird. Anyway, so let's close OBS here.